Welcome to Lecture 3, The Many Contexts of Software Architecture. This is your Professor Atif Fareed Muhammad. In this chapter that we are discussing in the third week, we're looking at architecture in a technical context, architecture in a project life cycle context, in a business context, in a professional context, who are the stakeholders, how is the architecture influenced, what do architecture influence, and we'll summarize in the end. Context of software architecture. Sometimes we consider software architecture the center of the universe. Here, though, we put it in its place relative to four contexts: technical, project lifecycle, business, and professional. What is technical? What technical role does the software architecture play in the system or system of which it is a part? In the project lifecycle, how does a software architecture relate to the other phase of the software development lifecycle? In the business, how does the presence of a software architecture affects an organization's business environment? Professional, what is the role of a software architect in an organization or a development project? The technical context, let's expand on that. The most important technical context factor is the set of quality attributes that the architecture can help to achieve. The architecture's current technical environment is also an important factor where standard industry practices are involved, software engineering techniques prevalent in the architect's professional community. Today's information systems are web-based, object-oriented, service-oriented, mobility-aware, cloud-based, and social networking friendly. It was not always so. It won't be so 10 years from now. Project lifecycle context. Let's look into this waterfall, iterative, agile, model-driven development in a little bit more depth. The waterfall architecture is a traditional linear approach to software development where each phase of the project is completed sequentially, like water flowing down a waterfall. In the context of developing a university management system, the process would start with the requirements gathering, where developers work with the university stakeholders to document all necessary features such as student enrollment, course registration, grade tracking, and faculty management. Once the requirements are finalized, the system moves to the design phase where the architects create detailed blueprints including database schemas, user interfaces, face layouts, and system workflows. This phase ensures that the system's structure aligns with the university needs before any coding begins. After the design is approved, the implementation phase begins, where developers write the code for the university system based on design specifications. Once the system is built, it enters in the testing phase, where quality assurance teams rigorously check for bugs, usability issues, and performance problems. For example, they might test how well the system handles the thousands of students registering for courses simultaneously. Finally, after testing it is complete, the system is deployed to the university and enters the maintenance phase, where developers address any issues that arises and make updates as needed. While the waterfall model provides a clear, structured approach, its rigidity can be a drawback. For instance, if the university later requests a new feature such as integrating online learning tools, the entire process might need to restart, making it less flexible compared to the modern iterative approaches like Agile. Now let's look into iterative and Agile in a little bit more depth before we go to the next slide. The iterative and agile architecture is a flexible and adaptive approach to software development, focusing on delivering small functional pieces of the system in cycles rather than all at once. In the context of developing a university management system, the process begins with planning and prioritization, where developers and university stakeholders identify the most critical features to implement first, such as student enrollment and course registration. Instead of designing the entire system upfront, the team creates the basic plan to start building a minimum viable product or MVP. For example, the first iteration might deliver a simple enrollment module that allows students to register for courses, while subsequent iterations add features like grade tracking, faculty management, and online learning tools. Each iteration involves designing, coding, and testing and deploying a small part of the system, followed by feedback from university users. For instance, after the initial enrollment modules is released, students and administrators might provide feedback on its usability, prompting the team to make improvements in the next iteration. This continuous feedback loop ensures that the system evolves to meet the university needs more effectively. Agile methodologies such as Scrum and Kanban emphasize collaboration, adaptability, and frequent communication, allowing the team to respond quickly to changes such as new regulatory requirements or the need for additional features. Unlike the rigid waterfall model, agile iterative nature makes it ideal for complex, evolving projects like university management system, where the requirements may change over time. This approach ensures that the system remains aligned with the university's goals while delivering value incrementally. Whereas model driven development is a software development approach that focuses on creating and using visual models as a primary artifact throughout the development process. Instead of writing code directly, developers create high level models that represent the system's structure, behavior, and functionality using standardized modeling languages like UML or Unified Modeling Language. These models are then automatically transformed into executable code using specialized tools, reducing the need for manual coding and minimizing errors. Architecture activities, all of these processes include design among their obligations. Architecture is a special kind of design, so architecture finds a home in each one. No matter the software development process, there are activities involved in the creating software architecture, using that architecture to realize a complete design, and then implementing or managing the evolution of a target system application. So there are 7 steps given making a business case for the system. We just had made a business case for a university management system. Understanding the architecturally significant requirements like the student registration at same time, course enrollment that can be at the same time, and fee payments or the finances dealing with the students are can be sporadic and can happen like in different times or diverse time frames. Creating or selecting the architecture, how would you go? Would you go like agile, iterative, waterfall, or model development? uh, Documenting and communicating the architecture, how you would share with the stakeholders, whether direct stakeholders or indirect stakeholders. Analyzing or evaluating the architecture for future expansion or enhancement of the system. Implementing the testing and the system based on the architecture and making sure or ensuring that the implementation conforms to the architecture. The business context is another example. Architectures and systems are not constructed frivolously. They serve some business purpose. These purposes may change over time. Let's look into this with an example. The business context in software architecture refers to the specific needs, goals, and constraints of the organization for which the system is being developed. It ensures that the architecture aligns with the business strategic objectives, operational requirements, and user expectations. For example, consider the retail company that wants to develop an e commerce platform to expand its online presence. The business context would include factors such as the need to handle high traffic during sales events, integrate with existing inventory and payment systems, and provide a seamless user experience across devices. The architecture must be designed to support scalability, security, and fast transaction processing to meet these business goals. while staying within the budget and time constraints. In this scenario, the business context also influences the choice of technologies and architectural patterns. For instance, the retail company might opt for microservices architecture to ensure that different components of the e-commerce platform, such as product search, shopping cart, and payment processing, can be developed, deployed, and scaled independently. This approach allows the company to quickly adapt to changing market demands, such as adding new payment methods or integrating the third-party logistic providers. Additionally, the architecture might include cloud-based solutions to ensure high availability and cost efficiency. By aligning the architecture with the business context, the e-commerce platform can deliver value to the company, enhance customer satisfaction, and drive revenue growth. Architecture and the business goals. Systems are created to satisfy the business goals of one or more organizations. Development organizations want to make a profit or capture market or stay in business or help their customers do their jobs better or keep their staff gainfully employed or make their stakeholders happy or a little bit of each. Customers have their own goals for acquiring a system, usually involving some aspect of making their lives easier or more productive. Other organizations involved in a project's life cycle, such as subcontractors or government regulatory agencies, have their own goals dealing with the system. Architects need to understand who the vested organizations are and what their goals are. Many of these goals will have a profound influence on the architecture. So let's look into this in a little bit more depth. A university management system is a complex software solution designed to streamline and automate various administrative and academic processes within a university. The architecture of such a system must align closely with the university's business goals, which typically include improving operational efficiency, enhancing the student and faculty experience, and ensuring data security and compliance. For example, the system might need to handle student enrollment, course registration, grade management, faculty workload tracking, and financial aid processing. To meet these requirements, the architecture could be designed using a modular approach where each functional area, such as admissions, academics, finance, is developed as a separate module. This modularity allows the university to implement and update specific components without disrupting the entire system, ensuring flexibility and scalability as the institution grows. One of the primary business goals of a university management system is to improve operational efficiency. By automating repetitive tasks such as student registration, attendance tracking, and report generation, the system reduces manual effort and minimizes errors. For instance, an automated enrollment module can handle thousands of students' applications simultaneously, ensuring a smooth and sufficient process. The architecture should support high performance and reliability, and during peak times like the start of a semester, this might involve using cloud based architecture to ensure the scalability and implementing load balancing techniques to distribute traffic evenly across servers. By streamlining operations, the university can allocate resources more effectively and focus on its core mission of educational and research. Another critical business goal is to enhance the experience of students, the experience for students, faculty, and staff. The system should provide intuitive interfaces and seamless access to information such as course schedules, grades, and financial records. For example, a mobile friendly student portal could allow students to register for courses, check grades, and communicate with professors from their smartphones. The architecture should support integration with other systems such as Learning Management System or LMS and library databases to create unified experience. Additionally, features like personalized dashboards and notifications can improve engagement and satisfaction. By prioritizing user experience, the university can foster more connected and supportive academic community. The architecture must address the university's need for data security and compliance. Universities handle sensitive information such as student records, financial data, and research findings, which must be protected from unauthorized access and breaches. The system should include robust security measures such as encryption, multi factor authentication, and regular security audits. Compliance with regulations like GDPR, General Data Protection Regulation of Europe, or FERPA, Family Educational Rights and Privacy Act, is also essential. The architecture should support role based access control, ensuring that only authorized users can access specific data. By providing security and compliance, the university can build trust with stakeholders and avoid legal and reputational risks. In summary, the architecture for a university management system must be carefully designed to align with the institution's business goals, ensuring efficiency, user satisfaction, and security while supporting the university's mission. Professional contexts. Let's look into this with a little different example of a clinical system. A clinical system is a software solution designed to support healthcare professionals in managing patient care, medical records, and clinical workflows. The architecture of such a system must align with the professional context of healthcare, which includes ensuring patient safety, improving clinical efficiency, and maintaining compliance with medical regulations. For example, the system might need to handle electronic health records or EHRs, appointment scheduling, diagnostic results, and treatment plans. To meet these requirements, the architecture could be designed using a service oriented architecture or SOA, where each clinical function, patient registration, lab results, prescription management, is developed as an independent service. This modularity allows healthcare providers to integrate the system with existing tools such as medical devices and or pharmacy systems and adapt to the specific needs of different departments or specialties. One of the primary professional goals of a clinical system is to enhance patient safety and care quality. The system must provide accurate, up to date, and easily accessible patient information to healthcare providers. For instance, a well designed EHR module can ensure that the doctors have complete medical history, including allergies, medications, and past treatments, and at their fingertips during consultation. The architecture should support real time data sharing and synchronization across departments, such as between the emergency room and the lab, to enable timely and informed decision making. Features like clinical decision support systems can further improve care quality by alerting providers to potential drug interactions or recommending evidence based treatments. By prioritizing patient safety and clinical system helps healthcare professionals deliver better outcomes and reduce medical errors. Another critical professional goal is to improve clinical efficiency and workflow. Healthcare providers often face heavy workloads and time constraints, so the system must streamline tasks and reduce administrative burdens. For example, an automated appointment scheduling module can optimize the use of resources such as doctors' time and examination rooms. While minimizing patient wait times, the architecture should support integration with wearable devices or telemedicine platforms to enable remote monitoring and virtual consultations, which are increasingly important in modern healthcare. Additionally, features like voice to text dictation or customizable templates can save the time for clinicians when documenting patient encounters. By enhancing efficiency, the clinical system allows healthcare professionals to focus more on patient care and less on paperwork. The architecture must address the professional context of data security, privacy, and regulatory compliance. Clinical systems handle highly sensitive patient data, which must be protected from breaches and unauthorized access. The system should include robust security measures such as encryption, audit trails, and role based access control to ensure that only authorized personnel can view or modify patient records. Compliance with regulations like HIPAA, Health Insurance Portability Act and Accountability Act, or GDPR as mentioned earlier, is also essential. The architecture should support features like patient consent uh, management and data anonymization for research purposes. By prioritizing security and compliance, the clinical system helps healthcare organizations maintain trust with patients and avoid legal or financial penalties. In summary, the architecture of a clinical system, which is a professional context obviously, must be carefully designed to align the professional context for healthcare, ensuring the patient safety, workflow efficiency, and regulatory compliance while supporting the delivery of high quality care. Now let's look into the stakeholders. Stakeholders or stakeholder is anyone who has a stake in the success of the system. There can be direct stakeholders, indirect stakeholders, and indirect stakeholders, as well as non-direct stakeholders. Stakeholders typically have different specific concerns that they wish the system to guarantee or optimize. You will need to know and understand nature, source, and priority of constraints on the project as early as possible. Therefore, you must identify and actively engage the stakeholders to solicit their needs and expectations. Early engagement of stakeholders allow you to understand the constraints of the task, manage expectations, negotiate priorities, and make trade-offs. The stakeholders can be developing organization management stakeholder, low cost, keeping people employed, marketing stakeholder, neat features, short time to market, low cost, parity with competing products, the end user stakeholders, behavior, performance, security, reliability, and usability. The maintenance organization stakeholder is modifiability, and consumer stakeholder, that is low cost, timely delivery, not changed very often. And architect is O, as you can see that. Know your stakeholders, talk to them, engage them, and engage with them. Listen to them and put yourself in their shoes and walk a mile. See the table 3.1 for the list of examples of stakeholders as just showed and their interests and concerns. How architecture is influenced. Requirements influence the architecture of a course, of course, but the requirements specifications only begin to tell a story. The software architecture is a result of business and social influences as well as technical ones. The existence of an architecture in turn affects the technical, business, and social environments that subsequently influence future architectures. In particular, each of the contexts for architecture plays a role in influencing an architect and the architecture. So, how the architecture influenced? The architect's influences on the business, technical, and project, and working with the stakeholders and professional context. And you can see the architect is right in the middle of architecture and the system. So this is the influence on the architect can be defined, and I can share with you a real story here. In the context of designing a virtual healthcare provision system, which I had a chance to work in 2013 for a hospital, I'll just not name the hospital system. I was, as an architect, I was a chief architect, and I was influenced by a variety of factors that shaped the system's architecture. One major influence is the technical requirements of the system, such as the need for real-time communication, data security, and integration with existing hospital system like electronic health records and diagnostic tools. For example, the system must support video consultation, remote patient monitoring, and secure sharing of medical data between healthcare providers and patients. So I had to make a choice of technologies and protocols that ensure low latency, high reliability, and interoperability, such as WebRTC for video. I'm just changing the video name, the technology names at this moment, for the sake of transparency and security, and HL7, And in these days, it should be FHIR standards for data exchange. These technical considerations directly impact the system's performance and usability, making them critical influence on the architect's decisions as well. So, if you're an architect, you have to make sure that you are taking care of the technical requirements seriously before you get influenced by any external stakeholder or any other need. Another significant influence is the regulatory and compliance requirements governing the healthcare system. So, I as an architect, must ensure that the virtual healthcare systems adhere to strict regulations like HIPAA, the Health Insurance Portability and Accountability Act in the United States, and GDPR, General Data Protection Regulations in Europe, which mandate the protection of patients' data and privacy. For instance, the system must include robust encryption for data transmission, secure authentication methods like multi-factor authentication, and audit trails to track access to patient records. Additionally, the architect must consider regional telehealth laws as well. So, if you are the architect, you have to be mindful of that, which may dictate requirements for licensing, consent, and cross border care. These regulatory constraints shape the system's design, particularly in areas like data storage, access controls, and user consent management. Finally, if you are an architect, so if I go in the third person form speaking, the architect is influenced by the needs and expectations of stakeholders, including healthcare providers, patients, and hospital administrators. For healthcare providers, the system must be intuitive and efficient, enabling them to conduct virtual consultations, access patient records, and prescribe treatments seamlessly. Patients, on the other hand, expect a user friendly interface, easy access to care, and clear communication with their providers. Hospital administrators may prioritize cost effectiveness, scalability, and the ability to integrate the system with existing infrastructure. For example, the architect might design a mobile friendly patient portal that allows users to schedule appointments, join video calls, and view test results, while also ensuring the system can scale to handle increasing demand during peak times like flu season. Balancing these diverse stakeholders' needs is a key challenge that influences the architect's design choices, ensuring the system delivers values to all users while meeting technical and regulatory requirements. What do architectures influence? The technical context, as I discussed in quite depth. So I will continue to the next slide here. Project context, I have also shared that with you. In this slide, the architecture affects on structure of the developing organization. An architecture prescribes the unit of software that must be implemented or otherwise obtained and integrated to the form of the system. So that is something that I thought to share with you in this slide in a little bit more depth. The business context, as we have done the business context for the university management system as well as the hospital or clinical system. So these notes on the slide are pretty much the revision of all that thing we have discussed so far. The professional context, we have went through extensively on the professional context story. However, let me summarize that by telling you the process of system building will affect the architect's experience with subsequent. A system that was successfully built around a particular technical approach will make the architect more inclined to build systems using the same approach in the future. Architectures must fail that fail are less likely to be chosen for future products. So the architecture influence cycle is given here for your review. The idea is when the business, technical, project, or professional influences happen on the architect, where business, technical, and project are the stakeholders. The architecture is come to be fruition, and a system is built. However, everything goes back from the architecture level to the system level to all the stakeholders involved, so they can make a call, and that is the call they make in terms of as an insightful decision making. So the system would be flawless or more likely near flawless even at the level of MVP, which is the minimal viable product. Architectures exist in four different contexts: technical, project lifecycle, business, professional, and since we have discussed that all in quite detail, so I'll not go in further depth. And architecture has influences that leads to its creation, and its existence has an impact on the architect, the organization, and potentially the industry. We call this cycle the architecture influence. Hopefully, this lecture has given you something to ponder upon. Stay tuned for your next lecture, uh, and we will be expanding our understanding in the system and software architecture. Happy learning.